Well, welcome everybody to Radio Pi. Today our guests are from White House Utility District. This is an update to a 2016 project that they did to visualize sensor-based data on their ArcGIS maps. So this is the Esri ArcGIS screens. Back then they told us how they got a value realization in only 3.5 days. So they've done a lot since then, including some very big detection successes. We're going to talk to them about that today. Just for some background, White House Utility is the largest water utility in Tennessee by geography, serving customers and businesses just north of Nashville. They believe that water is Earth's greatest natural resource, and their goal is to be good stewards of it, which, as you'll see in their examples today, is really just good business. So I'd like to start by introducing Pat Harrell, District Engineer. Hello, Pat.
Hey, how are you doing?
Oh, real good, thanks. And we're talking to Josh Gregory, Water Loss Analyst. Hello, Josh.
Hello, how are you?
Real good. And here's Kim Klotter, Wastewater Coordinator. Hello, Kim.
Hi, Nick. Good to be with you today.
Our co-host today is Gary Wong. He's the Industry Principal for Water here at AVEVA. Hello, Gary.
Hi, Nick. Pleasure to be here.
Well, thanks for being here, everybody. Let's start with Pat. What's it been like for you working through the pandemic?
Yeah, absolutely. We've never worked through anything like a pandemic, and I'm sure that hopefully we've learned a lot, and as things have progressed with COVID over the last year or so, we've had to change the way we do a lot of things. Our challenge is to provide life-sustaining services, water and sewer service. So we couldn't really just go home on something like that and wait it out. So our general manager, adopted a strategy early on of making sure that knowing that we were only going to be successful if we were able to keep our employees healthy, because they're our greatest asset, and we've invested in them really heavily over the last few years. So they're really good at doing their jobs, and without them, it wouldn't really matter how much technology we had or how our equipment ran. We've got to have them healthy and available. So last spring, we decided that the quickest way we could accomplish that was to distance our people from one another and from the public. So they're all used to being in the office, seeing each other every day and exchanging information face to face quite a bit. We're really connected by tools in a desktop environment in the office. So when we needed to be able to make those available to our employees remotely, we were really fortunate to already kind of have invested in Pi. And we had developed some applications and some solutions at a time that were ready to go before COVID started. But then they were really easy to move over to mobile devices, which is what we wound up using quite a bit to be able to share and display information and get the notifications and alarms through email that we were used to seeing. So yeah, Pi has helped a lot. As a matter of fact, we didn't see a drop in the level of service that we provided because we'd already started relying on these solutions, and we're able to put some new solutions through the year in place. So in fact, we were able to refine some things and build out some things throughout COVID that we had started before COVID. So we're really happy with where we turned out to be there, and we can look back on it, and we're happy to say that we think it definitely didn't impact us as bad as it could have.
Thanks, Pat. So look, Josh, can you tell us a little bit about the April 2016 project for taking such a variety of data sources and bringing them into your ArcGIS maps, into your Esri screens? What was the business case for doing that? How did you get such good results so quickly?
What we did to start with is we took our 600 square mile service area and tried to make it into smaller, more manageable pieces that we call district metered areas. We had several different data sources that, they went to their own location. With Pi, we were able to consolidate all those data sources to go to one location, which helped out, tremendously. And also for our DMAs, there were several KPIs that I was figuring manually. Well, with Pi, we were able to automate all those KPIs, which saved, several hours a day. And that was time that I was able to use to, better interpret and better understand the data that we're looking at. Pi allowed us to consolidate all that data. We were able to put it into, vision displays and GIS dashboards so that everybody throughout the district could consume that data.
Nice.
and for the first time, we were able to see what was happening, across the service area, and we used that actionable data to prioritize and find the more impactful, and more impactful generally means larger leaks. So that's getting the larger leaks got us kicked off good right off the bat.
So Josh, with better visibility, I'm just kind of curious, did you see any kind of low-hanging fruit where it's almost an unintended consequence of people having better visualizations than they did before? We hear about this all the time. Just exposing the data to people allows them to see things where they can just change their practices. Did you see any of that?
Yeah, I mean, one thing that comes to my mind right off the bat was, you learn how your system operates. We had water flow in some directions that we thought it flowed other directions, and found valves that were supposed to be open that were actually closed, and little things like that. So just aside from just the actual finding of the leaks, there's a lot of different little things we found out about our service area, just little tidbits, just extras.
Hi, Josh. With the sensors and the DMAs in place, I was just wondering if you could let us know how you're able to find more leaks or reduce the leak run times, and in terms of finding leaks much faster.
Yeah, well, to start with, I mean, I guess anything new, I guess we all had to develop a confidence in the data we're looking at, so we weren't, questioning the data, or we were just taking what it told us and going and trying to, find leaks. Better understanding of our infrastructure helped us to improve and cut the run times. We identified weak spots in our district. Some of them were known, weak spots. You just, through time, you find. But the thing is, we saw this data every day. So we didn't have to wait on a customer calling a leak or somebody to see it. We got a lot of rural areas, and a lot of times they're out there and they're never seen. They're in the middle of a field or whatever. But with this, I see the flows in our DMAs every morning, and we can react, quick, because we're not just waiting on something. We see it in the data. The flexibility of the software was a big thing. We set it up on paper, and most of it was good, but we saw a need to cut some of the DMAs further. And the software was very adaptable to the changes that we created, on the ground. It was easily navigated, and I could adapt it to the new system as it was.
So Josh, those changes, that better visibility, is that something that is an improvement that you can measure?
Yeah, the main way that we measure that is through the infrastructure leakage index. It's a way for utilities to measure non-revenue water against an industry standard. And 16, when we got going on this, our infrastructure leakage index, or ILI, was 1.49, and it's dropped, every year. And as of last year, we were at a 0.76. So that's the primary way we measure it.
Josh, so how has that changed how people work and all the institutional knowledge that goes along with it?
What it's done, it's made us responsive rather than reactive. In most cases, we can adjust to what the data says, and in a lot of cases, find a leak before it turns into an emergency. The guys in the field now have a lot of confidence in the data. We have one guy that he's been here about 40 years, and he did things a certain way for so long. So he was skeptical about what we were doing. But, as he's seen that, yes, the data is right, the data is telling us what it actually is, he's became a believer in it.
Okay.
So I mean, we do things completely different. We're able to prioritize areas and not just go aimlessly from connection to connection, just not knowing where the leakage is actually at.
Now, that example you just described, it sounds like it brings up the whole issue of institutional knowledge that's leaving a lot of organizations. Is this helpful in addressing that?
Yeah, that's what this has done. We rely on data now rather than institutional knowledge.
Right. Okay. Well, here's a question for anybody. Do you have any recent examples that you can take us through of really kind of high-profile leak detections where this has come in real handy?
Yeah, just here a couple weeks ago, I came in, like I do every morning. I checked all the workflows in all my zones. And I noticed one had spiked a little. It hadn't spiked enough to be priority yet, but it had spiked some. So I watched it, and the next day it went up some more. So then it was priority. What we did, we create what we call sub-DMAs. We can do them overnight, or we can do them during the day, and then read our variety of DMA meters. What we'll do is we'll close valves to create a smaller zone inside of the larger, and the GIS helps with that tremendously because the guys in the field can just go on there, choose the valves that create a smaller zone, and read a meter, and then that'll tell you how much is there. So what we did for this leak, we started like we always do with what I mentioned earlier, the weak spots in the infrastructure. Well, this one was a little different, a little contradictory because, most of the time it is the weak spots that are giving the trouble. That's why we go there first. But this one wasn't in any weak spots, so they looked over. So then once we eliminated a lot of area by just eliminating the usual weak spots. And then what we did, we continued to make sub-DMAs, and we started by closing valves, get the flows in a zone, you open some valves back up, you squeeze it tighter and tighter and tighter. And then we got narrowed down to a small stretch of 12-inch PVC. I think it was about 2,000 feet of it.
Wow.
So then the guys in the field, they started using their subsurface listening device to try to find it. And what they found was it was in a driveway. The line come cross country, and then it came through a guy's driveway. There wasn't a drop of water on the ground anywhere. But then when they dug down and found it, it was probably about 175 gallon a minute leak that I saw that zone go back to normal the next day.
Wow, very cool.
Pat, I've heard you talk about advanced pressure management. I was just wondering if you could let us know how you're using the sensor data.
We historically monitored pressure from our existing SCADA sites for, over 20 years, but really those were fixed monitors that reported to SCADA, and they told us what was going on right near pumps, but we mainly used that data to just evaluate pump operation and did a little bit of planning with it, but we really didn't apply it to leak detection or to trying to prevent leaks in the field. So the leak loggers that we have now, we're able to deploy those and remotely collect data for several different purposes. One of those things we use those for is at customer services, where we can monitor customer data at their meter, at their house. We can also deploy those out in our system and monitor our pressure reducing stations. So, both on the customer side for their private equipment and our public equipment on the mains, that's mechanical equipment, and it's prone to failure, and they can fail or they can creep out of adjustment. So what we were finding is we would manually go to these sites to check these pressures. We would find that those settings would drift. So what would happen is pressure would either go above the desired pressure or below it. But if we've got real-time data collection, we're able to see those changes before they get out of hand and cause major problems. So in the past couple of years, we've also become really interested in pressure transients. That was something that we didn't pay attention to, or really didn't even know about maybe 5 or 6 years ago. But the new sensors that we have are capable of monitoring the transients, which is, we'll talk about that maybe a little bit later and expand on that, why that's important to us.
Yeah, I mean, how does that help? So you're you're able to see when you're getting transients, the spikes in pressures. What does that allow you to do?
Yeah, like you mentioned in the beginning, we got a huge service area and about 1,100 miles of pipe. So we can't be everywhere at once. We can't just collect manual measurements everywhere to see when either high or low pressures or transients are occurring. So we use a continuous monitoring and let the data come back to us and let it work for us so we can focus our efforts where we know that problems are. And we also can use things like Pi applications to crunch the numbers for the data. And then what that does is it really conserves resources. So we're able to limit the number of in-person site visits to go out into the field and drive out there physically to those locations, either confirm operation of equipment or to manually collect data. So as an example, we've got several dozen pressure reducing stations, and just one round trip, driving trip to those for a person, they got to drive over 200 miles to cover that area. So it's really going to allow us to cut down on those sorts of things. And then we'll have better data as well. We were manually collecting that information before, and these are things now with automatic data. We can set alarms based on the thresholds that are unique to each location. And then when the alerts occur, we get those notifications to let us know when we need to go visit a spot and see what's going on. Okay. So, all of that helps us continue to lengthen our asset life and cut down on burst events.
Was there any specific set of events that made you decide to do it this way?
Josh has made some incredible progress by just looking at flow data on non-revenue water and reduce that volume in the past several years, like you mentioned. But if we wanted to continue to improve, we knew we were going to have to eliminate things like burst events where you figure out what's causing the breaks in the first place. So if we're going to reduce non-revenue water, he's not doing necessarily every possible thing he can do, but he's really got that under control. So if we can address the burst events, we think there's a lot of ground to be covered there. So with we looked at 3 sections of pipe where we were having really high break frequencies in the last several years, and we were averaging about 1 break per month on these 3 sections of pipe, which is that's excessive. I think in anybody's book, and it definitely was for us. So those things are really costly. We lose a lot of water. It's very disruptive for our customers because they were burst events where they actually lost service completely, not just a leak, but a break that occurred that took them out of service. So, our image was really suffering because of that activity. So we collected data around those areas, and, it came to us that they were around water pump stations and or valves that were opening and closing in the system. And what we found was happening is the operation of the equipment had for years and years been operating in such a way that it was creating transients, pressure transients. So as pumps start too fast or stop too slow, or valves open too quickly or close too quickly, the water movement starts and stops quickly and creates those transients, and it was really damaging the pipes. So we modified the operation of our pumps where we slowed their ramp-up times and slowed their shutdown times. Same thing with the valves that were causing the transient, slowed the opening speeds and closing speeds, and then use those pressure monitors to confirm that the transients had been eliminated with that adjusted operation. So now we've just pretty much virtually eliminated the breaks or the burst events in these area. And, as we were, we invested maybe $10,000 in the equipment to do the monitoring. And with those 3 areas where we were thinking we're going to have to replace the pipe work, we saved about $2 million in capital improvements that we didn't need to construct because we were able to eliminate the transients. So, our customers also get the benefit of this because those transients were being transferred into their private plumbing. And not only does it keep our breaks from happening on our side and in public infrastructure, but the customers also enjoy that. So it also lets us get a higher level of service to them in that respect on their private side.
Kim, now there's another optimization you all at White House Utility District have done, and that involves inflow and infiltration. Can you describe that issue and what your solution was for it?
Sure. Like most utilities that operate a wastewater collection system, we're always trying to reduce the amount of I&I or inflow and infiltration that get into the system. And I&I is groundwater or stormwater that seeps in through defects in pipes or manholes or even illegal connections into the system. And this water really is relatively pretty clean, but once it seeps into the system, there's a cost associated with that now. We have to pay to treat this excess water. So our system is divided into 2 zones, and much like Josh was able to break down his DMA zones into smaller and smaller pieces looking for leaks, we were able to break down our sewer zones into smaller pieces looking for I&I. And each of our subzones have a pump station, and they all have SCADA monitoring, and we were able to pull flow and rain data from each station into asset comparison tables. And we added some formulas so that we could look at the I&I and the cost associated with each subzone. And doing that, we were able to see really easily where our problem areas are and kind of where we needed to focus. And so once we had that target zone, we're able to deploy some portable flow meters and kind of break that subzone down even more. And then compare the flows with among those meters and see okay, this little section of this subzone is now our target. And basically we're narrowing it down until we get to the neighborhood level or the street level, and we kind of hone in on that source of I&I, and we're able to make the repairs or modifications to eliminate that now. And so having this targeted approach is a real improvement over just heading out into the rainstorms and hoping that we get lucky.
Hi, Kim. So with so much more information coming in, how are you using some of that pressure data around your air release valves?
Sure, Gary. Similar to how PAD is using pressure data to optimize the water distribution system, we're using pressure data to monitor and maintain our sewer force mains and extend the life of our pumps and equipment within the system. All of our, or not all of them, but we have air release valves installed along our sewer force mains. And these valves allow entrapped air to escape from within the pipe. And, that reduces the pressure within the pipe, but it also reduces the pressure over the whole system so that our pumps upstream aren't having to overcome as much pressure to push that wastewater downstream. And so the less pressure there is within the system, the less wear and tear that there is going to be on the pumps, and the more water that we can pump downstream with that same amount of energy. So on all of our air release valves, on
Sure.
some of our air release valves, we have these pressure recorders installed. And Pi allows us to see and compare the pressure label or pressure levels at our pump stations that have SCADA monitoring, but then also the pressure on throughout our system with these pressure recorders. And with this being integrated into our GIS, we're also able to see all of our sites across the system and see the historical data that's associated with each of these sites. And one powerful element of this is that we're able to package all of this information into maps and dashboards and integrate that into our asset management software. And that really helps because when our field staff is out trying to make an urgent decision, whether it's restoring service to our customers or maintaining service to our customers, they're able to quickly and easily access all of this data in one platform.
I was curious if all of the things that you've been doing, the optimizations, are they in service of any kind of greater goals, corporate-wide, sustainability, that type of thing?
Yeah, a lot of the corporate goals we've got would in just a bullet point list, one of those first things would be, equipping our really good employees with actionable data. We want to do that to empower them so that they can make better decisions and have a better insight into our system. Furthering a digital transformation really is, it suits our people in the GM's vision well. We don't want to adopt applications, just for the sake of technology, but we want those to work for us, and this allows us to do that. Another big thing that you've heard Josh and Kim mention is integration with GIS. So we make use of the Pi integrator for Esri ArcGIS. It's a great way to visualize things and then keep up with things geographically. So with that, along that same theme where we've got the large geographic area, knowing where things are and what's going on with them is a big deal for us. We're also able to, improve our image and the public trust as we're able to show them things that's backed by data, not just by opinions or thoughts that we might have. We're also able to show good stewardship with our money, our time, the natural resources, and then improving service to our customers is the overarching goal for all of this. We're a utility, so we don't necessarily have competitors in the area. So what our general manager really pushes is that service is the thing that we need to be known for, and that we have to strive to do that the best we can. So all these tools really help us do that.
Well, that's fantastic. I was just wondering if there's anything else that you've done in the last 12 months around operational efficiency, asset reliability, anything else that you'd like to share?
Sure, Gary. I'd like to note that our wastewater team is really small. And for us to be able to automate such a significant portion of our operations, it really frees us up to, focus on other things within our department. We used to do a lot of time-based inspections, once a week, once a day, or once a week, once a month. We'd be going back and doing these same, routine tasks. But now we've moved to more condition-based inspections, and a lot of that repetitive work is just being eliminated, and we're able to focus on what really needs our attention. And when you have a small group, that's really important for us.
All of the impacts that from the things that you've heard Josh and Kim mention, and then some of our other stuff where we're eliminating a lot of the burst events, all of that relates back to energy consumption. So just by virtue of doing a better job in those areas without specifically pursuing energy, we've seen a lot of gains in that area. But we're working with our power providers now to do more of an in-depth study and seeing how we might do load shedding or timing of power use so that we can do that more efficiently and then as well for at a reduced cost for our customers. But that's what's ahead for us, is we are able to get the right power monitors in place and then start looking at that to try to conserve power.
Well, good. That's it. That's all the questions I wanted to ask. Actually, I hope you don't mind. I'd like to ask you a quick lightning round of questions. Since you're all working in operations, the culture of operations is certainly unique. I'm just kind of curious. What would you say if you're at career day and you're telling school children what you do for a living? Who wants to go first?
We get to play with the coolest toys known to man.
Well, I got to admit that the question I want to ask is what were those unauthorized connections to the system? Kim, is that really a thing in your industry?
Oh, well, sometimes we do find where roof drains are connected to the system. Maybe they were put in, years and years ago, but instead of draining out into our yards, they'll go into the sewer system, or, sometimes sump pumps from folks' basement will be connected to the sewer system. And no, nothing too lurid, but we do find those type of connections sometimes.
Okay. So it's career day at school. What do you tell them?
We're responsible for providing wastewater and water service to a lot of customers, and it's a pretty cool field. We wind up providing life-sustaining water to people, and it involves fire protection, drinking water, irrigation for plants, and then taking that water away as it's used, and then taking it to treatment facilities and making it useful or appropriate to discharge back into the environment for use again. And all these tools we've been talking about today are very cool, and we're fortunate to have those available to us to be able to do that better.
Now, I know you were saying that White House Utility District is the largest geographical water service in Tennessee. You must have some absolutely beautiful views that nobody else in the state gets to see. What's the best view you've ever seen? Anybody?
Well, the views from the water tanks have got to be probably the best things that I've seen, getting on top of those a few hundred feet up in the air, and then they're on top of the beautiful ridges here in Middle Tennessee. A lot of pretty scenery.
Right, right. Well, thank you so much, everybody, for being our guests today. We've been talking to Pat Harrell, Josh Gregory, and Kim Klotter at White House Utility District. Thank you so much for being our guest today.
Enjoyed it.
Great, thank you.
You're welcome.
Thank you.
Thanks, Kim. Thanks, Josh.
And Gary Wong, our co-host today, thank you so much for joining. Everybody who's been viewing, thank you so much. We'll see you again in another 2 weeks. Bye-bye.